Good morning everyone. So we are in the second part of the tutorial 6 of the Econometrics tutorial series, right? So in the first part of our tutorials we have discussed up to the fourth question, right? Now today we are going to discuss about the fifth question of the tutorial 6. So in the fifth question it says that using the same data set from the question 3, answer the following questions. So in the first part A, they ask explain what is a moving average model mean. So you have previously we have discussed about the AR model. Now in this section they are asking what is mean by this moving average model, right? So if I move to my whiteboard, previously we have discussed about the AR model, right? So previously we have discussed about the AR model. So what is mean by this AR model? Simply AR model says that the present value of a variable is a function of its past values, right? And what is mean by this MA model? Simply the MA model says that the present value of a variable is determined by its current and previous year's error terms, right? So under the AR model what we say is the present value of a variable is a function of its past value. So if we want to get the present value of a variable, what we have to use is we have to use the past values, right? But in the MA model we said that the present value of a variable is determined by based on the current year and the previous year error terms, right? So that means the present value of a variable in the MA model is determined by based on the current year and the previous year error terms, right? එතකොට මේ AR මොඩල් එක ගත්තම AR මොඩල් එකක කියන දේ තමයි variable එකක present value determine වෙන්නේ ඒකේ past value මත base වෙලා කියන එක. හැබැයි MA මොඩල් එක ගත්තම කියන්නේ variable එකක present value එක determine වෙන්නේ previous year සහ මේ එකේ කලින් අවුරුදු වල සහ මේ අවුරුද්දේ තියෙන error term වල බලපෑම් මත තමයි මේ අවුරුද්දේ MA මොඩල් එක තීරණය වෙන්නේ. එහෙම නැත්නම් මේ අවුරුද්දේ present value මොකක් හරි variable එකට අදාළව present value එක තීරණය වෙන්නේ current year එකේ සහ previous year එකේ error term මත කියන එක තමයි මේ MA මොඩල් එකේ සරල idea එක. හරිද? So if we move to your lecture slide, in here you have discussed about the moving average model, right? So in here you can see that this is the equation that we are using for determining the MA model. So in here this is your present value, right? This is your present value, and this is your current year error term. And this is your previous year error term, right? So students, you can remember that in the AR model, the type of AR model we have determined based on the number of previous year values included in the equation, right? So in the moving average model or the MA model is applying the same method. So in here we have used only one previous year error term. So that means this is a MA1 model. So if we move to this kind of a situation, in this kind of a equation, here we have previous year 1 and this is the previous year 2. So this is a MA2 model. Because there are two previous year value. So the number of MA2 is determined by MA term value is determined based on the number of previous year values that was incorporated in the model, right? So if we move to our tutorial, so the first question is asking explain what is the moving average model mean. So I have explained that part. Now we are moving to the second part of the question. The second part of the question is asked use GDP as the variable for the MA model and identify the level at which GDP becomes stationary, right? So now they ask us to use the GDP as the variable for MA model and identify at which level the GDP becomes stationary, right? So I will go to my eViews. Then you can directly import from the recent file, or else what you have to do is go to file, then click import and import from file, and then select your dataset, right? So in here select the predefined rate as sheet 2, but the data is in the sheet 1, so I will select the sheet 1 and then click finish, right? Then set no for this, and your dataset will be imported for the eViews software, right? So now they ask us to calculate or identify in what level the GDP becomes stationary, right? So to identify in which level the GDP becomes stationary, what we have to do is double click the GDP, then go to view, and I'm going to use the unit root test as it is the easiest one. And unit root test, standard unit root test type is ADF test, and firstly we are going to conduct this test on the level data, and I'm selecting the trend and intercept here, then press OK, right? So we can see that the probability value of the ADF test is greater than 0.05. that means the GDP is not stationary at its level data. So I'm going view again, unit root test, standard unit root test, instead of the level data. Now we are going to check the stationary at first difference, so I will press OK. So now the probability value is less than 0.05. that means the GDP is stationary at its first difference, right? So now we have done with the second part of that question. Now they ask to determine the appropriate order of the MA model for GDP using the autocorrelation function, right? So what they ask to do is determine the appropriate order of the MA model, right? So by using the autocorrelation function, right? So I will go to eViews. So I will go to eViews and I select the GDP. I double click the GDP here and go to view, then select the correlatum, and it is asked to at what level we want to do. Now previously we have identified that the GDP becomes stationary at its first difference, right? So I will select the first difference here and then press OK, right? So now we have determined the appropriate MA model for GDP, right? So previously in the AR model, the appropriate AR model type was determined based on the partial autocorrelation, right? But in here now we are in the MA model, and in the MA model appropriate order of the MA model is determined based on the autocorrelation, right? So the criteria for identifying the number of MA term is similar to the criteria that we have used in the AR model, right? So the first criteria is there should not be any systematic pattern in here, and also if we say a variable or the one is significant, that means one is significant if any of the values in here go beyond this significant level or go beyond these two dotted lines or these two boundaries. So in here we can see that this is the only point, only lag that go beyond the significant level. So to determine the type of the MA model or the order of the MA model, what we have to do is you have to use the autocorrelation function, and in the autocorrelation function you have to look about two things. First thing, you have to make sure that there is no any systematic pattern in this autocorrelation function, and then you have to identify what are the lag terms that go beyond this significant level. So in our case there is only one lag that go beyond the significant level, so that is the lag 1, right? So this is a MA1 model. So if we go to the tutorial, so they asked to determine the appropriate order of the MA model. So the appropriate order is MA1, right? And we have identified the stationarity in here. So we know that now we know that GDP becomes stationary at its first difference, right? Its first difference. So in the last part of the question, they asked to estimate the MA model and interpret the results. Now we have to estimate the MA model and interpret the results that we have get, right? So to do that, I will go to eViews and then go to quick estimate equation. In here you have to type your equation, right? So we know that GDP is become stationary at its first difference, so we have to take the first difference here. So first I'm going to type D, then in brackets I'm typing GDP, then you will pop up this window, then you can double click it here and close the bracket, then constant C and identify the number of MA terms. In here we have the MA1 only, so I will be typing MA1, right? And let's say for the moment there is there is another lag that was significant in here. Let's say the lag number 10 was significant in here, then you have to type MA10, right? MA10, right? So for the moment in this section only a MA1 is significant, right? So I will press OK now. So you will come up with the results. You will come up with the estimated results, right? So in the section they ask estimate the MA model. Now we have done with that part, and interpret the results that we have obtained through this estimated, right? So now we are going to interpret the results. So first we are looking at the R square of the model. It is around 20%. That means the explanatory power of the model is around 20%, right? And now we are moving to F statistic. If we look at the probability value of the F statistic, it is less than 0.05. That means overall model is significant. And if we look at the probability value of the individual variables, we can see that the T statistic probability value related to the T statistic is every variable is less than 0.05. That means each independent variable is significant, right? And now we are going to talk about this coefficient. So when talking about this coefficient, we can write the equation for the DGDP like this, right? First I will split my screen for my easiness, and here is our whiteboard. So if we are going to estimate the equation or prepare the function for the DGDP in this MA model, we can write it as a DGDP is equal C plus MA1, right? This is our equation. So if we add values for this DGDP plus, instead of C we can write this coefficient value. I write 2.9 E plus 11 into the MA value is 0.42 MA, right? So this is the function for DGDP, or this is the function for determining the present value of the GDP, right? With that, students, we have completed the fifth question as well. Now we can move to the sixth question. Try to do that the sixth question by yourself by pausing the video from here. I hope everyone have tried to do the third question by yourself. So now I'm going to explain the third question, right? Before moving into the sixth question, I have another small thing to clarify for you, right? So in the MA model, we said that the MA model consists with the current year error term and the previous year error terms, right? And based on the previous error term, we identify the order of the MA model, right? So in the equation that I have wrote here, you can see the MA1. So this is the previous year error term, but you can't see the current year error term, right? So the current year error term is within this model. That means the current year error terms is already included in this model and you can't separately see it, right? So though we have said the current year error term is like this, it is already included in the model and you can't separately see it. So because of that, you can only see the previous year error term or the error terms, right? So now we can move to the next question. So in the sixth question, they are asking, using the same data set from the question 3, answer the following question, right? So in the part A, they ask, explain the difference between the ARMA model and the ARIMA model. So you have learned about the ARMA model and the ARIMA model in your lecture, and now they ask to identify the difference or they explain the difference between these two models, right? So first we are going to discuss about this ARMA model, right? So as this name suggests, you can see there is AR term and there is a MA term. So simply this ARMA model is a combination of AR model and the MA model. Simply this ARMA model is a combination of the AR model and the MA model, right? But to run this ARMA model, there is a special condition that you need to be satisfied. There is a special condition. So the condition is to run the ARMA model, all the variables to run the ARMA model, all the variables or all the data in your data set, should be stationary at its level data. So to run the ARMA model, there is a special condition. The condition is all the data in your data set should be stationary at their level data. So you can't differentiate and run the ARMA model. So to run the ARMA model, you have to have your all the data at stationary at its level data, right? So next model is the ARIMA model. So in the ARIMA model also you can see there is AR term and there is a MA term and there is another symbol called I, right? So in here this is the AR model, this is the MA model, here this is the AR model and this is the MA model, and this is the I mean the integration or level of the integration or the level of the differencing that you have done. So in the ARIMA model, simply what happened is, in ARMA model we know that you can't run the ARMA model if the data are not stationary at level data. So in the ARIMA model, what happened is, to run the ARIMA model, data should be stationary at their differencing level. So that means the data should be stationary at either in the first difference or in the second difference. So then only you can run the ARIMA model. So in here the AR is the AR model, MA is the MA model, and I is representing the level of integration or level of differencing in the model. So that is the difference between the ARMA model and the ARIMA model. In the ARMA model, all the data should be stationary at its level data, and to run the ARIMA model, your data should be stationary at the first difference or the second difference, right? So now we are moving to the part B. In the part B, it says that using the GDP as the dependent variable estimate an ARMA model, right? Using the GDP as the dependent variable, estimate an ARMA model. I think, students, this GDP is not stationary at level data, right? So in here we have checked the stationarity of GDP in the level data, and we have found that it is stationary at its first difference, right? So here the GDP, the variable is not GDP, it should be changed as the exchange rate. So in here the dependent variable is not the GDP, it is the exchange rate, right? And so now what we have to do is, using the exchange rate as the dependent variable, we have to estimate the ARMA model. So I will go to eViews. Then firstly I will check whether the exchange rate becomes stationary at its level data. So I will double click the exchange rate, go to view, unit root test, standard unit root test, and I will select the ADF test, and I'm doing this test on level data, and I will select the trend and intercept, then press OK. So the probability value is less than 0.05. That means the exchange rate become stationary at its level data, right? So now we know that to run the ARMA model there is a special condition, that is all the data in the model should be stationary at level data. So now we are running the ARMA model using the exchange rate, and we have checked that the ARMA model, the exchange rate becomes stationary at its level data. So now we can run the ARMA model, right? Okay, so to run the ARMA model, you have to identify number of AR model and the MA term, number of AR terms and the MA terms. So to do that, what you have to do is, you can go to eViews, then double click on the exchange rate, then click here view correlagram, and we are identifying the correlagram at our level data, then press OK, right? So here we have the autocorrelation and the partial correlation function. So based on the partial correlation, we are identifying the number of MA terms, right? Based on the partial correlation, we are identifying the number of AR terms, right? And based on the autocorrelation, we are identifying the number of MA terms, right? So students, you can see that all in the both autocorrelation and partial correlation, there is no any systematic pattern you can see. But and also, and the second condition is, to identify the AR term or MA term, one of these variables should go beyond this significant level. One of these variables should go beyond this significant level, right? But here we can't see anything that go beyond the significant level. Here in the partial correlation, we can see this is slightly go beyond the significant level, but here we can't see anything, right? So to identify a lag or particular variable is significant, it should be definitely go beyond these two lines, right? But for the moment we can't see anything that go beyond the significant level. So let's assume that this is almost in the significance level now. So let's say this is also, let's assume that this autocorrelation value is also go beyond the significant level for the moment. So now we have identified one term, and that is the lag level, right? We have identified lag level of both of this autocorrelation and the partial correlation has go beyond a significant level. Now we can run the ARMA model. So to run the ARMA model, what you have to do is, you can go quick, then click estimate equation. In the estimate equation, our dependent variable is the exchange rate. So you can type EXCH, and then it will pop up the variables you have. So exchange rate, and then press C for the constant, and I will add in my ARMA model. So our AR term is AR11 and MA term is MA11, and then press OK. So this is your ARMA model. This is your output for ARMA model, right? So in here you can see that your R square and adjusted R square is very low, and the overall model is not significant, and each of these ARMA terms or AR term and MA terms are not significant because we see that there is nothing or there is no any variable that go beyond this significant level. So we did based on the assumption, right? So this is your ARMA model. එතකොට තමයි මේ ARMA model එක run කරන්න නම් අපි AR term සහ MA term කියන දෙක identify කරගන්නේ මේ auto correlation කියන function එකයි partial correlation එකයි කියන මෙන්න මේ diagram දෙක පාවිච්චි කරලා. එතකොට මේ වෙලාවේ එකක්වත් ඔයාලට පේනවා මෙන්න මේ dotted line වලින් එහාට ගිහින් නැහැ මේක lag value එකක්වත්. හරිද? මෙන්න මේක lag value එකක්වත් මේකේ dotted terms වලින් එහාට ගිහින් නැහැ. එතකොට හරිනම් අපිට මේ වෙලාවේ ARMA model එක run කරන්න බෑ. but ඔයාලට කියලා දෙන්න ඕන හින්දා අපි assume කරමු වඩාත්ම ළඟ තියෙන දෙක. දැන් මේක නම් ගොඩක්ම ළඟයි මෙන්න මේ ඉරට, ඒකත් එක්කම මේක නම් මේ ඉරේම වගේ තියෙනවා. ඒකින්ද අපි assume කරා මේ මෙන්න මේ 11 කියන lag එකේ තියෙන auto correlation එකයි partial correlation එකයි lag දෙක මෙන්න මේ significance level වලින් එහාට ගියා කියලා. එහෙම assume කළා තමයි අපි මෙන්න මේ model එක run කරන්නේ. ඒතර මෙන්න මේ model එක run කරාට පස්සේ මේක තමයි ඔයාලට එන output එක. එතකොට ඔයාලගේ බැරි වෙලා හරි model එක ඔයගොල්ලෝ run කරන්න යද්දී මෙන්න මේ විදිහට significance level වලින් එහාට යන්නේ නැත්නම් ඔයාලට මේකේ ARMA model එක run කරන්න බෑ. මොකද ARMA model එක significant වෙන්නේ නැහැ. හරිද? So with that we have done with the estimation part of ARMA model. So now we are moving to the part C. So in the part C it asks to using the exchange rate. Here it is not the exchange rate. It is not the exchange rate. You have to use the GDP instead of the exchange rate. You have to use the GDP. So what you have to do is using the GDP as the dependent variable, using the GDP as the dependent variable, estimate an ARIMA model. So now you know that in the ARIMA model, AR is the number of AR term and MA is the number of MA terms. I is representing the differencing or the level of integration, right? So you know that in order to run the ARIMA model, the variable should be stationary after we conducting the differencing, right? So in the GDP we know that the GDP becomes stationary at its first difference level, right? GDP becomes stationary at its first difference, right? So if I go to eViews and check that whether it is correct or not, I will double click on GDP, then go to view, unit root test, standard unit root test. Firstly I will conduct it on level data, so you can see that probability value is greater than 0.05. so I will go again view, unit root test, standard unit root test, and we are now conducting the unit root test in first difference, then press OK. So now it is less than 0.05. that means the GDP becomes stationary at first difference, right? So now we are going to run the ARIMA model. So to run the ARIMA model, what you have to do is you have to identify number of AR terms and MA terms. So to do that, double click on the GDP, then click view, correlogram, and now we are running this at our first difference because the GDP becomes stationary at first difference, then press OK. Okay, now here we can see that by using the partial correlation we are identifying the number of AR terms, and by using the auto correlation we are identifying the number of MA terms, right? In here we can see that the first leg or the first variable is go beyond the significant level, right? In the previous case when we are estimating the ARMA model, we can't see anything go beyond like this, but in here we can see that this first leg is go beyond its significant level, right? So now we are going to estimate the ARIMA model based on this. So to do that, what you have to do is go to quick, estimate equation, and your dependent variable is GDP, but not the GDP at the level data, it is at the first difference. So to represent the difference, I type D, then within brackets I will type GDP and close my bracket, C, and our AR term is AR1 and MA term is MA1, right? So this is your equation. So this is the AR term, this is the MA term, and you know that in the ARIMA model there is something called I. In the ARIMA model there is something called I, and I said that this I is representing the level of integration. So in this equation the DGDP is the I, that means we are taking this at the first difference, so the I is 1, right? So now I press OK, then you will come up with the results for the your ARIMA model. So in this ARIMA model results you can see that the R square value is around 25% and overall model is significant based on the overall significance of the model. And you can see that AR term is both AR term and the MA terms are greater than 0.05. that means both of these AR term and MA terms are not significant, or both of these AR term and MA terms doesn't have a significant impact on the DGDP, right? So with that we have done with the part C as well. Now we have estimated the ARMA model and also we have estimated the ARIMA model, and now they asked to, in the part D, they asked to, based on the ARIMA model estimated in the part C, so we have estimated the ARIMA model in the part C, and run an ARIMAX model by including the inflation as a independent variable. So students, sorry, so in the part D they asked to estimate the ARIMAX model. So in ARIMAX model what happened is they introduce in a new variable called X. For the ARIMA part we have previously, and now they have introduced something called X. So this X means a independent variable. This X means a independent variable. So that means to this ARIMA model that we have run, we have to incorporate the independent variable, and they have give the independent variable that we need to incorporate, that is inflation. So what we have to do is you have to re-estimate this ARIMA model by incorporating inflation as an independent variable. So I will go to eViews, and in here I will go to estimate. So this is the ARIMA model we have estimated. To here you have to add inflation as your another independent variable, right? So I will double click it here and then press OK. So this is your ARIMAX model. So in here you can see that the R square is around 35% and 30%, and the overall model is significant because the probability value of the F statistic is less than 0.05, and we can see that the inflation becomes significant because it is less than 0.05, but both of these AR term and MA terms doesn't have a significant impact, or both of these values are less than 0.05, that means they are not significant, right? So this is the output for ARIMAX model. So if we move to tutorial, so now we have done with the part D as well. So in the part E it is asked evaluate whether the ARIMA model estimated in the part C is suitable for forecasting. So we have estimated the ARIMA model in the part C, and they ask whether it is suitable for forecasting, and you have to check it by using the graphical method and also using the ARMA root method. So in the part C we have estimated the ARIMA model. You have to check the suitability of that ARIMA model for forecasting using the graphical method and the ARMA roots method. එතකොට කිව්වේ මෙන්න මේ ARIMA model එක අපි run කරා part C එක. දැන් අපිට කියනවා මෙන්න මේ run කරපු ARIMA model එක suitable ද කියලා බලන්න forecasting වලට graphical method එක සහ ARMA root කියන method දෙක පාවිච්චි කරලා මෙන්න මේක check කරන්න කියලායි අපිට කියන්නේ. හරිද? එතකොට so first I'm going to eViews and rerun the ARIMA model. to do that, I will remove the inflation from this equation and then press OK. So this is your ARIMA model, right? This is your ARIMA model. So to identify whether this is suitable for forecasting, first there are two methods that you can use. You can either use a graphical method or you can use ARMA routes, right? So first we are going to discuss about the graphical method. So to identify whether this model is suitable for forecasting, what you have to do is to identify whether this model is suitable for forecasting using the graphical method. What you have to do is you have to go to view in your output window, then click actual and fitted and residuals, and here you have to select the graph. Without not the table, you have to select the graph, right? So you will come up with the graph like this. In this graph, blue line represents the residuals and orange line represents the actual values. Orange line is representing the actual values and green line representing the fitted values, right? So fitted line means simply you can say it's like a estimated value. So you can see that the green line is already almost similar with all, that means almost go with the orange line, right? That means the estimated values are almost similar to the actual values. So and there are no any significant variations. Almost these two are similar, right? That means both of these lines are closer. කිව්වේ මෙන්න මේ තැඹිලි පාටින් පෙන්නන්නේ actual line එක, කොළ පාටින් පෙන්නන්නේ estimated figures කියලා හිතන්නකො. එතකොට මෙන්න මේ තැඹිලි පාට line එකයි කොළ පාට line එකයි කියන දෙකම ගත්තම මේ දෙකම ගොඩක් වෙලාවට ළඟ ළඟ තමයි move වෙන්නේ. ඒතර මේ දෙක අතර ලොකු variations වලට බලාගන්න නැහැ. ගොඩක් වෙලාවට මේ දෙන්නම එක ළඟ තමයි move වෙන්නේ. So based on that we can say that the model is good for forecasting because actual values are similar, the forecasted values are similar to its actual value. So because of that we can say the model is suitable for forecasting, right? So now we have done with the first method of graphical method. Now you have to identify using whether this model is suitable for forecasting using the ARMA routes, right? So to find the ARMA routes, what you have to do is go to eViews, go to view ARMA structure, and here select the routes and display it as a graph. Then you will come up with a graph like this, right? So in this graph, AR routes will be represented in this blue dot and the MA routes will be showing in this orange dot, right? So this is the blue dot is the AR route and the orange dot is the MA route. So how we decide that whether this model is suitable for forecasting is based on whether this AR route and MA route are within this circle, right? If the both MR and MA and AR routes are within this circle, we say that the model is suitable for forecasting. So in here you can see that both the AR term and the MA term are, MA routes are within this circle. So we can conclude that this model is suitable for forecasting, right? ඒකෙවිලමයි මොකක් හරි මොඩල් එකක් ඒක forecasting වලට සුදුසුද කියලා බලන්න පාවිච්චි කරන්න පුළුවන්. තව මෙතෙක් තමයි ARMA routes කියන එක. ඒතකොට මේ blue dot එකෙන් පෙන්නනවා AR routes, orange dot එකෙන් පෙන්නනවා MA routes. එතකොට මෙන්න මේ AR routes සහ MA routes කියන දෙක ගත්තාම මෙන්න මේ දෙක මෙන්න මේ තියෙන circle එක ඇතුලේ තියනවා නම් අපි කියනවා මේ වෙලාවේ මේක suitable වෙනවා forecasting වලට කියන එක. හරිද? So with that we have done with the part E. Now we are moving to the last part of the sixth question, right? So students, in the sixth question it is asked to, using the final ARIMA model from the part C, forecast the values of the exchange rate from 2022 to 2026. So initially in the part C we have run the ARIMA model for using the GDP as our variable, and we have in the part D we have checked whether it is suitable for forecasting or not, and we have determined that the model is, or the ARIMA model is suitable for forecasting under both of these two methods. And now finally what we are going to do is, now we are going to forecast the value, and the question asks to forecast from 2022 to 2026, right? So if we move to our e-views, so in your data set you can see the range is from 1980 to 2021, right? This range is from 1980 to 2021. So now the question says that you have to forecast the data from 2022 to 2026, right? So since the sample size is now 42 observation, or there are only ranges, the range is from 1980 to 2021, before forecasting you have to increase this range, or you have to increase the number of sample, or you have to increase the sample size. To do that, what you have to do is, you need to go the prop menu here, then go to the structure or the resize current page, right? Click here and you can see the end date of the data set and the start date and the end date of the data set, right? So in here you can change this 2021 to 2026 and the frequency is annually, then click OK, right? Then it says that resize involving inserting 5 observation, we say yes, right? So now if we go to the GDP, you can see that in here you go to view spreadsheet. So in the spreadsheet now you can see that new years have been added, but you can see that the values, or the values for the data for these particular years have not been added yet, right? So you have to now forecast those values. So to do that, what you have to do is, first you have to go to your estimate result. So these are previously estimated result. So I will go to estimate here, and this is our ARIMA model that we have estimated. So I press OK. So this is our estimated result. So in this estimated result window you can see something called forecast in here. So you have to click the forecast, and here since we are now forecasting the GDP, not the difference GDP, so here we are selecting the GDP, and the forecasted name is the software is automatically generated as GDPF. They added a F to represent the forecast, so I will keep it as it is, and I will select the forecasting method as a dynamic forecast. And you can see that the forecast sample is now from 1980 to 2026, right? Previously it was around 1980 to 2021, right? Now then I will click OK, right? So you will come up with this kind of a graph. This blue line is your forecasted value, right? So, and you can also see that in this window there is another variable has appeared as GDPF, right? If I open both this GDP and GDPF together, you can see that in the GDP column the values for 2022 to 2006 are not available, but from in the GDPF the values have been added. These are the values that we have forecasted, right? එතකොට අපි මේ වෙනකම් කරපු ටික ගැන කතා කරොත් එහෙනම් මුලින්ම කරන්න ඕන දේ තමයි ફોකස් කරන්න යන්න අපි ඉස්සරහට. එතකොට අපි sample size එක මදි. ඒතර මෙතන මේ crop menu එකට ගිහිල්ලා ඔයාලගේ sample size එක මුලින්ම වැඩි කරගන්න ඕනේ. ඒ කියන්නේ මෙන්න මේ data වල range එක වැඩි කරගන්න ඕනේ. data range එක වැඩි කරන් ඉවර වෙලා ඔයාගේ estimate කරපු result එක, ඒ කියන්නේ ඔයා estimate කරපු ARIMA model එක තියෙනවානේ. මෙන්න මේ ARIMA model එක කියන model එක through තමයි අපි දැන් focus කරන්න යන්නේ. ඔයා අතර වෙන model එකක් පාවිච්චි කරලා focus කරන්න යන්නේ. ඒ අදාළ estimate කරපු model එකට ගිහිල්ලා මෙතනින් මේ focus කියන එක දීලා තමයි එතනින් එහාට step ටික continue කරන්න ඕන. ඒතර ඒ විදිහට focus කරාට පස්සේ ඔයාලට මෙතනින් අලුතින් variable එකක් add වෙනවා GDPF කියන එක තමයි අදහස් වෙන්නේ forecasted කියන එක. හරිද? ඒතර ඔයාලට finally මෙන්න මේ විදිහේ result sheet එක බලා ගන්න පුළුවන්. ඊට පස්සේ so now we want to check whether these forecasted figures are aligned with the actual figures. These are the forecasted figures and these are the actual figures. So since we have the actual data till the 2021, we can compare these actual figures with the forecasted figure and identify whether these forecasted figures are okay or they are accurate. So to do that, what you have to do is you can go to quick, then select graph. In here you have to type the variable. The first variable is GDP, right? So GDP is the actual results, and again GDPF. GDPF is our forecasted result. Then press OK. Then here you have to select the graph type as a basic type and specify it as a line and symbol graph. Then press OK. So you will come up with a graph like this. This orange color graph is your forecasted line and the blue line is your actual result. So you can see that in around 2000 to 2005 there are some variance between, some gap between the actual result and the forecasted value, but at the end it will become closer, right? So if we move to the tutorial, so they ask, using the final ARIMA model from the part C, forecasted value for the exchange rate from the year 2020 to 2026. So these are the forecasted value, and here we have checked the accuracy of the forecasted values, right? So with that, students, we have completed the tutorial 6 completely. So hope everyone understand what we have done so far. If you have any question, you can ask us from any time. Thank you everyone for your participation.